As an HVAC technician, part of your job is going to be installing, repairing, and servicing domestic hot water. Domestic hot water is potable water that is heated to be used for cooking, cleaning, and bathing. Potable water is water that is safe enough to be consumed by humans. The four most common domestic hot water systems you will encounter are direct water heaters, which is the picture on the upper left, indirect heaters, the picture on the upper right, tankless coils for boilers, the picture on the lower left, and tankless direct-fired water heaters, which is the picture on the lower right. Direct-fired water heaters store hot water in a storage tank. Hot water comes from the top of the tank, while a cold water line at the bottom of the tank replenishes it. Depending on the type of fuel the water heater uses, some form of burner warms the cold water entering the tank. With a gas system, a thermostat opens the gas valve as the water temperature falls, then a gas burner under the tank heats the water. The valve closes when the temperature rises to the desired temperature. Oil-fired water heaters operate similarly, but they have power burners that mix oil and air in a vaporizing mist, which is ignited by an electric spark. The typical electric unit is wired to a 220-volt circuit. To heat the water, the current passes through electrical resistance heating elements, usually two, one at the middle of the tank and one at the bottom. Indirect water heaters work a lot like direct-fired water heaters. Instead of having its own heat producer, indirect water heaters use the home's boiler to heat the water. The water passes through a coiled pipe called a heat exchanger that is in the storage tank. Indirect water heaters allow the boiler to turn off and on less often, saving you energy. Because of this, indirect water heaters tend to be a more efficient option than a tankless coil. Tankless coils use the heat from a boiler to transfer heat to the domestic water. The coil is actually bolted into the boiler, but it's like an entirely separate system. The coil itself is basically a long run of copper tubing with fins cut into the outside of it. The inlet and outlet of the coil are only a few inches apart from one another, but there's quite a bit of pipe in between. By the time the cold water gets through all of the pipe, it comes out very hot on the other side. Tankless water heaters heat water directly without the use of a storage tank. When a hot water tap is turned on, cold water travels through a pipe into the unit. Either a gas burner or an electric heat element heats the water. As a result, tankless water heaters deliver a constant supply of hot water. You don't need to wait for a storage tank to fill up with enough hot water. However, a tankless water heater's output limits the flow rate. Typically, tankless water heaters provide hot water at a rate of 2 to 5 gallons per minute. Gas-fired tankless water heaters produce higher flow rates than electric ones. Sometimes, however, even the largest gas-fired model cannot supply enough hot water for simultaneous multiple uses in large households. For example, taking a shower and running the dishwasher at the same time can stretch a tankless water heater to its limits. To overcome this problem, you can install 2 or more tankless water heaters connected in parallel for simultaneous demands on hot water. You can also install separate tankless water heaters for appliances. On these last few slides, I'm going to explain some of the parts you will find on different domestic hot water systems. On all the systems discussed so far, with the exception of the tankless water heater, you will find a thermostatic mixing valve. A thermostatic mixing valve, or TMV, is a valve that blends hot water with cold water to ensure constant, safe shower and bath outlet temperatures, preventing scalding. The storage of water at high temperature removes one possible breeding ground for bacteria. It is increasingly common practice around the world to regulate the storage water temperature to above 140 degrees Fahrenheit and to circulate or distribute water at a temperature less than 122 degrees Fahrenheit. Many countries, states, and municipalities now require that the temperature of all bath water in newly built and extensively refurbished domestic properties be controlled to a maximum of 118 degrees Fahrenheit. Installing thermostatic mixing valves can ensure that water is delivered at the required temperature, and it also reduces hot water consumption from a supply that is maintained at a higher temperature by blending cold water with it. Heat traps are valves or loops of pipe installed on the cold water inlet and hot water outlet pipes on water heaters. The heat traps allow cold water to flow into the water heater tank but prevent unwanted convection and heated water to flow out of the tank. Most new water heaters have built-in heat traps. For water heating equipment that does not already have factory-installed heat traps, they must be either purchased or installed with piping with a minimum of an 8-inch heat trap in the inlet and outlet connections. Heat traps are very simple and inexpensive. They are an effective way to prevent cooling of hot water in water heaters by thermosiphoning. Thermosiphoning is based on natural convection. Hot water rises and is then displaced by cold water. The heat trap stops this process, thus keeping the hot water inside the insulated storage tank. A vacuum relief valve is a simple device that prevents collapse of a water heater or storage tank. It is required on bottom feed water heaters or top feed water heaters without a dip tube that has an anti-siphon hole in it. If the building's water line were shut down, the system can back siphon the cold water line. The vacuum relief valve is located above the water heater and will open to the atmosphere when a back siphon occurs. This allows air to enter at the vacuum relief valve and the heater tank will not be drained down. This protects the heaters from dry firing the elements or burner and prevents the tank from collapsing. Found on residential water heaters, the temperature and pressure valve, or T&P valve, was designed to relieve pressure from a water heater if it reaches excessive pressures and temperatures. Since water expands when heated, the T&P valve was created to monitor the changes of the water heater to keep it from malfunctioning or exploding due to the heating process. Thermal expansion is the reason a T&P valve is needed on hot water tank. As the contents of the water is heated, it will expand up to a half a gallon when heated to its thermostat setting. Excessive pressure for the water heater tends to be around 150 psig. An excessive temperature would be 210 degrees Fahrenheit. The T&P valve protects the water heater by discharging water when it reaches excessively hot temperatures and high pressures, making it an excellent indicator of whether or not the water heater is functioning properly. If the water heater is operating normally, there should be no water discharged from the T&P valve. If the valve seems to be discharging water, that's an indication that there's a problem with the system. For most water heaters, an anoid rod is attached to the top of the water heater. The anoid rod is often referred to as a sacrificial rod. Most water is rarely pure. It can contain oxygen, magnesium, fluoride, chlorine, and other suspended particles. These components in the concentrations in your water are usually not bad for you. They do, however, impart a slight conductivity to the water. Through an electrical process called electrolysis, this conductivity will eventually, over a long period of time, cause most metal to corrode. When the water is heated, this electrical process can be accelerated. Most water heaters are made of a steel tank with a porcelain enamel glass lining. However, due to production and assembly methods, it is not always possible to completely cover the inside of the tank. Therefore, it's important to provide metal that can be consumed by the electrical process. This is where the sacrificial anode rod comes in. By acting as a lightning rod for the corrosion process, the rod draws the harmful electrolytic process from the water heater and focuses the corrosion on the rod. All domestic hot water systems will have a thermostat. The thermostat tells the system when to heat the water up. On most electric hot water tanks, they have two elements and two thermostats. The elements do not heat up at the same time. The top element heats the water first, and then the bottom element kicks in. The upper thermostat on an electric water heater acts as a coordinator between the two elements. When the water in the top of the tank is hot enough, it lets the lower thermostat go into action. When the lower thermostat senses the water is too cool, it turns on the lower element. This happens only after the upper element has finished heating. Instead of electrical resistant elements, gas-fired water heaters have a burner that's fed gas through a control valve and a thermostat switch. In an oil-fired heater, the burner is similar to that found on an oil-fired furnace or boiler.